Hey everyone, this is Tommy from Austin Mesh, and we're going to talk a little bit about this wire and how it's going to help this antenna perform much better today. So here's our plan. I'm going to go through it real quick for those of you who don't want to watch the whole thing. Then we're going to go over the setup and what we're doing here, talk about radials and how those are going to help us, talk a little bit about how you can tune, and then we'll talk a little bit about these babies over here. All right, so the short version is here's a nano VNA. It's measuring our standing wave ratio, or SWR, on the blue line, so that line there. And the x-axis here starts at 880 megahertz and ends at 1,000 or 1 gigahertz. Meshtastic by default operates at about 907, which is where that marker is. And so we want that marker to be as close to the bottom of the graph as possible on the y-axis. Right now, it's measuring 2.3. That's pretty bad. But you can see, even if I grab this antenna, see how everything changes? So if I touch this, so this is why tuning an antenna is important and having it freestanding in space is important. So we're going to talk a little bit about radials, and in order to do this, I have to set this down here. So sorry you don't have a view at the moment. Actually, maybe I can get you a view. All right, you can just barely see it. We're gonna add this ground plane, or this radial, to act as a ground plane to the bottom of this antenna. And as I do that, the SWR over here is adjusting. So, okay, we've got this tucked under here and wrapped around the bottom, hanging out a couple inches. Now you can see our antenna has adjusted a little bit. Let's just wrap this a little bit further so that the radial is shorter. You'll see how that goes up. The SWR is going higher. Now if we extend this to be long, see, now that SWR is moving to a lower frequency. So we just need to keep pulling this out a little bit, making it a little bit longer until it's the right length for our antenna. So we're almost there. See, our dip is a little bit high. Let's keep pulling it out a little bit more. It's a little bit longer yet. Ooh, we're getting really close. And if I'll pull it out just a tiny bit more. Okay, we're just about perfect there. Now we're measuring 1.06, and that's where we want to be. So we are using the Laird MA9 5N whip. If you're interested in figuring out good antennas for Meshtastic, go to rfindex.com. This helps you compare all the various antennas. It's a good tool. All right, so let's talk a little bit more about the setup that we've got going here. So this is just an enclosure, small solar enclosure that I had running, and I popped everything out so we could use it for this. But we've got the Laird MA9 5N antenna into a N to IPEX bulkhead, and then this is a SMA to IPEX adapter, and we've got just SMA into our nano VNA, which is calibrated. It's calibrated at this point here. If you're familiar with calibration, we use these end caps here for, let's see, open, load, and short. So that helps us calibrate. So we're already calibrated on this thing. And obviously, earlier in the video, we added this ground plane here. And ground planes, we added the radial. And a radial acts as a ground plane for like a whip antenna, or specifically a monopole antenna. Monopole meaning it only has one of the two legs that are required for an antenna. So you wouldn't need something like this if you were, say, mounted to the top of your car and there was conductivity from this outside, this base, to if your car was steel or aluminum. But if it was fiberglass, you would need something like this, right? So what it's doing is it's acting as that other leg of the antenna. So it's pretty easy to calculate the size of this for your antenna, but in my experience, I've found that when we're doing something with Meshtastic, the distances are so small that it's actually much easier to slowly either pull it out or cut it back until you're tuned right on your Nano VNA. So you can do this without a Nano VNA by guessing, but you're going to be much better off if you have the VNA to actually measure things. This is going to seriously increase the performance of your antenna. I mean, if you're sitting at okay, let's pull this thing off of here. Let's see. So we're sitting at 2.2 SWR. That's not very good, right? But with it, we're sitting at 1.1, a little bit below 1.1. We're gonna have much better performance. I don't know what the percentage gain on that. Maybe one of you antenna nerds can tell me in the comments, because I don't know offhand. So you really suffer without getting that SWR down, and that radial makes a big difference. All right, and finally, I want to give a little special shout out to the Austin Mesh community here. These are from actually our local school district, the Austin Independent School District, and special shout out to Mr. Andy Shin here. He has just done so much for this community, from 3D printing to designing to helping the kids learn stuff. And so we have a great partnership with them doing STEM education here. They're learning about weather and prediction and hardware and software. It's a really cool thing. So if you want to know more about that, there's a bunch of great info on our website. That's it. Thanks for watching. Hope you all learned something about radials today.